clay is a family of minerals, which it's called hydrous aluminum phyllosilicates, and it's smaller than 0.002 millimeter. So very, very small particle. And hydrous, it means the mineral contains water. Aluminum, because it's one of the main components. Phyllosilicates means, phyllo means leaf in Greek, and it's a specific class of silicate minerals with a sheet-like structure, like we can see here. And not all minerals that are, or not all particles that are smaller than 0.002 millimeters are clay particles, though. Some are inert quartz, so 10 to 20% are inert quartz, metal oxides, and carbonates. The clay, as we heard before, it works as a binder in our cup and plaster, and which holds the aggregate particles together. It is formed through weathering of silicate-containing rock, such as feldspar. It's mostly feldspar, and we divide primary clays and secondary clays. The primary clays, they remain at the site of the rock, and they are light. That's why they are light colored. They are pure, and they are found at the site of formation. They are called, usually it's kaolinite, and they are used for porcelain or fire bricks, because they are very they can tolerate heat very well. And the secondary clays, they are displaced from its source, and that's why they change the color, because they get mixed with other minerals, and that's why many times they are reddish, ochre. So what do you think do we have here? Secondary. Right. It has been replaced over a long period of time. And it has more plasticity, the secondary clay, and it's often used, for example, for tiles on the roof. Oh. And for cup. How to identify and find clay? If you see the ground, an old lake bed or cracks in the ground, it's a sign for clay soil. And if you find puddles or lakes, many times, or it's probably because it contains clay, so it seeds the ground. These are some indicator plants: reed, willow, and mint. If you see them, it's many times a sign for clay. And common colors are red, ochre, and blue-gray. You find it in the subsoil, so you always dig beneath the top layer, and then you check if your soil is clay. And road cuts, landsides, and cliffs are good places to find clay. You understand why?
What's a road cut?
A road cut is like when, for example, like what they did here. They cut the road into a slope, because then you can see all the different layers. And sometimes the topsoil, there's the topsoil, then there's a layer of clay, and then there's another layer with more sand and gravel and so on.
And usually it'll come to the surface because the clay particles are way less than, for example, sand particles.
Because they weigh less, you say?
I think so. Like if you put them in the jar, they'll separate. And usually you'll have the clay layer.
Yeah, that's why. That's because the sand. Okay, these are. How can we understand if it's clay? We can do some field tests. my favorite test to, if I many times on hikes I find clay, and then, or I'm not, I think it's clay, then what I do, I take a bit of soil, I wet it, and then I do the squish test.
That was it.
So if you squish the wet soil in your hand and it comes out like a sausage, it's a good indicator that it is clay. If you squeeze it and water drops out, it means it's not clay but silt. Many times it's not obvious right away to distinguish those two. And yeah, here I say if water comes, silt is all right. Then another test is the crush test. You do it with dry clay, like you make you take a lump or you make a small ball, let it dry, and then you try to compress it in your hand. Usually, if it has a lot of clay, it's pretty hard to do it, but if it has a lot of silt and sand, it just breaks apart. It kind of explodes. The crack test is a good test as well. You take humid or wet clay and you make like again a sausage, and you roll it around your finger, and the harder it cracks, the more clay it has. But also, if it's primary clay, it cracks quite easy still, because it has less plasticity.